Good morning.
Good morning.
Morning.
Good morning.
All right, well, let's see. Is everyone there in Joseph City?
Yeah, Avery's here, but he's in the hallway.
All right.
He'll be here in a minute.
Okay. All right. Good. Okay. And then how about in Holbrook? Who are we missing today?
Caitlin and Cyrus.
Okay. All right, so today we are going to finish 4.2 and go on to 4.3. Let's see. So, any questions, comments, concerns before we get started? All right. Okay, so So I had asked you to do practice 2B and 2C. So if you haven't done those, you might do those really quick. Let's call on somebody for those. So, all right. So Rebecca, do you have the answer for practice 2B? Or do you want me to give you a little time?
No, not yet. I'll have it in a moment.
Okay. All right. So when you have the answer, let me know. So remember when we were setting it up right as class ended on Tuesday, and you had to have a placeholder here. So there's no x squared term, so you have to add in a plus 0x squared in the dividend. Be right back.
kind of stuck.
Okay. So you look at the leading terms and say what times x squared is 3x cubed?
X.
So 3x. So you write a 3x up there, and then you multiply all the way through. So 3x times x squared is 3x cubed. 3x times 2x is 6x squared. 3x times 1 is 3x. So then you have to change the signs of all of the terms. So here I'm changing the signs, boom, boom, boom. Okay, the first one goes to 0. Then you have negative 6x squared, and then 4x minus 3x is just x. Bring down the negative 2. See, if you didn't have the placeholder, then this is where you'd be messed up. Okay? All right, now you look at the leading terms again. What times x squared is negative 6x squared?
Six.
Negative 6. So you put a negative 6 up there. Then you multiply through again, and so you have negative 6x squared minus 12x minus 6. And change the signs, boom, boom, boom. This goes to 0. This goes to 13x. This goes to 4. So x squared won't divide into 13x. So that means this 13x plus 4 is your remainder. And so you write your plus, then your remainder over the divisor. So the final answer should be written like this. 3x minus 6 plus, and then the remainder, 13x plus 4, over the divisor, x squared plus 2x plus 1.
Okay, thank you. That makes sense.
You bet. Any questions on that? All right, so we said that we can also do long division when we have complex coefficients. So let's do an example of that. All right. Let's just go ahead and do the practice problem together. Okay, so here we have 2x cubed minus 3ix squared plus 11x plus 1 minus 5i. So see the 1 minus 5i, that's your constant term. There's no x. Okay, but you still put it in there and your dividend, just how it is, as all your placeholders. And then 2x, so your constant here is minus I in your divisor. So it looks a little weird when you're setting it up because you have some terms with i's in it. Okay? All right, so did anyone try this and want to see if they got the right answer before we start going through it? Anybody tried already? All right, well, let's just go through it. So you look at the leading terms. So 2x and 2x cubed. So what times 2x would give you 2x cubed?
X squared.
X squared. So you write the x squared up there. All right, then you multiply through. X squared times 2x is 2x cubed. X squared times negative I is negative I x squared. Change the signs, boom, boom. So this middle term goes away. And then you have negative 3ix squared plus ix squared. So what would that give you when you add these two together?
Negative 2ix squared.
Correct. And then you bring down the next term, 11x. Okay? All right, now, again, you look at the leading terms. So what times 2x would give you negative 2ix squared.
Negative ix.
Negative ix. So you write that up there on top. So now you're going to multiply. So negative ix times 2x is negative 2ix squared. Negative ix times negative I is positive. And then I squared is negative 1 times x. So it ends up being a negative 1x. But then you got to change the signs. So you change the signs, boom, boom. So you got to be a little careful because initially you think, okay, negative times a negative is positive. But then I squared makes it a negative 1. And then you change the signs and it goes back to positive again. So that's really easy to mess up right there. All right, now the first term goes to 0. And then you have 11x plus 1x. So that's going to be 12x. And you bring down now, the reason why you bring down both of these, 1 and then minus 5i, is that they're both considered the constants here. Okay? All right, so now looking at the middle term, the leading terms. What times 2x is 12x?
6.
6. So you put a plus 6 up there. So 6 times 2x is 12x. 6 times negative I is negative 6i. So change the signs, boom, boom. So the x's cancel, but there's nothing to really combine with the 1, so you just bring that down, so you'll have 1 plus I. So that's your remainder. So you write your answer as your quotient, x squared minus I, x plus 6, plus, and then the remainder, 1 plus I, over the divisor, 2x minus I. All right. Any questions? All right. So next I'm going to show you a shortcut. And the shortcut is known as synthetic division. Now, the synthetic division is way easier. And I would only teach synthetic division except you can't do it in every problem. So there's only a limited number of problems that you can use it. And as it says here, the algorithm for synthetic division works only for divisors of the form x plus or minus a constant. Okay. So if your divisor is 2x or x squared or something like that, it doesn't work. All right. So let me show you how you set it up. Okay, so let's say, so just kind of watch this. Okay, don't write it down. It'll be easy, but you got to follow along what's going on. So you still have to have when you're setting up a division problem, the two things that we looked out for Tuesday, you still have to look out for. Can anyone tell me what those two things are? Okay, you have to have your polynomials in descending order, and you have to have your placeholders. So you still need that for synthetic division. Okay, so here we have x cubed, x squared, x, and a constant. No worries. It's in descending order. We don't need any placeholders here. Okay? So now what we do is we start off with just writing down the coefficients. -2, 8, -9, and 7. And then in a little magic box over here, we put the opposite of this number here. So the opposite of -2. So we put +2 and a little magic box over here. Okay? Then what we do is we're going to, we just bring down the first number. Okay? So the -2 just comes right down. All right? Then we take the -2 and we multiply it by the number in the magic box. So -2 times 2 is -4, and we write it under the 8, and then we add. Okay? So there's no changing signs, and we're adding instead of subtracting, and so there's less errors on synthetic division than on regular polynomial division. Okay, then you continue. Multiply, 4 times 2 is 8. You write that under the -9, and then add. -1 times 2 is -2. You write that under the 7, and you add and get 5. Now, this last number here is very important. That's the remainder. The next number to the left is the constant. Then the next number to the left is the coefficient of x, and then finally the coefficient of x squared. So now you just use that to write your answer. So you have -2x squared plus 4x minus 1, and then the last number, you write the remainder over your divisor, x minus 2. Now, whatever the power is in your original dividend, so we start with x cubed, the power in your answer should be 1 lower, x squared. Okay? All right, so let's see if you can do practice 3A, please. And I'll leave this one up for a minute. All right, so Anna, when you've got the answer, let us know.
I got x plus 2 plus 3 over x plus 1.
Beautiful. Okay, great job. Any questions on that? All right. Okay, synthetic division can also be used to evaluate a polynomial function f of x at x equals k, because p sub k, the p of k is the remainder. Okay, now this part, I don't know why I was never taught this in high school. And I'm going to tell you, this is a great shortcut for evaluating polynomials. I actually didn't learn this until I was teaching Algebra 2 my first year as a high school math teacher. And I'm like, are you kidding me that this would have been such a great shortcut? Okay, so let me just kind of show you what I'm talking about here. So let's say we wanted to find the p of 5 for this polynomial. Okay, see, normally what I would have done for years is just plugged in 5 everywhere there's an x. Okay, and then worked it out. But what you can do is do the same thing with synthetic division. So you write down the numbers. Again, you have to have placeholders. So -2, 11, -5, -3, 15. And then now the number that you're evaluating, you put that in the magic box. Okay? And then you go through the same thing. You bring down the -2, then you multiply and add. Multiply and add. Multiply and add. Multiply and add. So this remainder, this last number here is your answer. So the p of 5 is 0. Okay?
So in this case, you don't flip the sign of what you're...
Correct.
Yeah.
So whatever number you're evaluating, you just take that. That is your answer. Okay? And so I'm going to tell you that's a whole lot easier than having to raise things to powers and whatnot. Okay? All right, so let's have you go ahead and do practice 3B. All right, so Cottrell, when you've got the answer.
Equals to -17.
-17, let's see. Bam, great job. Okay. And so see the math required here, adding and multiplying. I mean, it's actually pretty easy math. Whereas if you had to start plugging stuff in and cubing it, and this math can get really crazy right away. And you might need a calculator when you're plugging in. But when you do it by synthetic division and your answer is just a remainder, it's much easier. And you would get the same answer, -17, if you plugged it in. Okay? But and so I love that shortcut. That's a great way to evaluate a function. Okay. All right, any questions on that? All right, so just as with long division, we can perform synthetic division on polynomials with complex coefficients as long as the divisor is in the first degree. So again, you can't divide by x squared or 2x or whatever, but and so normally I say x plus or minus some number, but that some number can be a complex number and it will still work. Now, the thing is that, you know, synthetic division is supposed to be a shortcut, but I have found that more students make mistakes with complex numbers on this. I'm not quite sure. And so typically I would just say, you know, maybe stick to the polynomial division, okay? So you're not required to do synthetic division on something like this. You can just do the polynomial division like we did back in practice 2C, okay? So you can just do it that way. But I'm going to go ahead and show it. I'm going to go ahead and show it with synthetic division, and then you can copy it down and decide if you want to use that or not. You're not required to know this, okay? So let's say I wanted to do this by synthetic division. The first kind of trick, and maybe this leads to a lot of mistakes with students, is remember it's x minus something. And so it's like you have to factor out the negative. And so what goes in the magic box is 1 minus I, not 1 plus I. So that's kind of the first tricky thing. The second tricky thing is we still have to have all of our placeholders. And see, notice that there's no x cubed. And so that's another thing that students would mess up on synthetic division. But somehow with polynomial division, if they mess it up, they realize it, you know, as they're lining it up. And whereas when they're just numbers, they don't pick up on it. Okay? But, so when we set it up, see the coefficients are going to be 1, negative 2, 2, and see there's no x cubed, so we put a 0 there, and then a 4, negative 8, and 8. And I've intentionally made this long and hard, you know, as far as synthetic division. So now we divide by a 1 minus, or 1 minus I is what is going to go in the magic box. Okay? So we still bring down just the first number. All right, then we multiply. 1 times 1 minus I, and so we get 1 minus I. Now, remember when we're adding here, you add the real parts and you add the imaginary parts. So negative 2 plus 1 is negative 1, and then you just bring down the negative I. All right, next, we need to multiply 1 minus I times negative 1 minus I. So how do we do that? Anyone remember how we multiply complex numbers together?
Foil it.
Foil it. Very good. Let's see. So here I've got it down here. 1 minus I times negative 1 minus I. So 1 times negative 1 is negative 1. And then you have negative I. And then negative I times negative 1 is positive I. And negative I times negative I is positive I squared. So then the i's cancel. And then negative I squared is negative 1. So this is just going to become negative 2. So that's nice. You put a negative 2 up here. And then when you add, you get 0. 0 times anything is 0. You add and get 0. 0 times anything is 0. You add to the 4 and you get 4. right, now 4 times 1 minus I is going to be 4 minus 4I. So then when you add, you're going to get negative 4 minus 4I, because you add the negative 8 and the 4 together, and then you just bring down the negative 4I. All right, we're almost done, but now we need to multiply this together. Negative 4 times negative 4 minus 4I is, we got to multiply that by 1 minus I. All right, so I'll let you do that one. So multiply these together and then put it under the answer underneath the 8 here. All right, so Jill, what do you get?
I got -8.
Negative 8. And so then when you add it to the positive 8, you get 0. Okay? So here's the work foiling that out. You get negative 8. Did anybody see a shortcut to multiplying those two together? I obviously didn't see the shortcut until now as I'm teaching you guys. See, I realized that negative 4 minus 4I is just 4 times this. Negative 1 minus I. So if I took the answer here, negative 2, and multiply it by 4, I'd get negative 8. But I didn't see it until I'm just seeing it now. Okay? Sometimes you can see little tricks like that could help you. But anyway, normally you have to FOIL it out. You have to FOIL it out. Okay? All right, so good job, Jill. So now now we write our final answer. So this is the remainder, 0. Negative 4 minus 4I, that's the constant. 4 is the coefficient of x. And then we have 0x squared and 0x cubed. And then negative 1 minus I is the coefficient of x to the 4th. And then 1 is 1x to the 5th. And so remember our answer, the degree is 1 lower than, see, we started with x to the 6th. And so our answer starts with x to the 5th. All right? Any questions on that? All right. All right, part 4. Constructing polynomials with given zeros. So if k is a 0 of a polynomial function, if and only if x minus k is a factor. So like if 3 is a 0, then that means x minus 3 is a factor. All right. So if it says construct a polynomial that has given properties. So it's fourth degree, and the zeros are -5, -2, 1, and 3. And it has a y-intercept at 0, 15. Okay? So if the 0 is -5, then what's the factor?
X plus 5.
And then what factor has a 0 of -2?
X plus 2.
And what factor has a 0 of 1?
X minus 1.
And then finally,
X minus 3.
all right. So everybody okay with that? Okay, now, if we didn't have this little part right here, we'd be done. Or sometimes you might see the answer foiled out, multiply it out. So you'd foil these, foil those, multiply them all out. So, but I mean, this is technically correct. Or you might see the answer multiplied out. The problem, though, that we have to check is the fact that we also have a y-intercept of 0, 15. So what some students want to do is they want to put a plus 15 at the end. And that's absolutely wrong. You can't do that. Because then these wouldn't be zeros. Okay? You'd have 15. So what you do is plug in 0 for x. You plug in 0 for x, and you just see what would you get. Would you get 15? Well, no, you would get 30. Okay? So then what do we multiply 13 by to get 15? What do we multiply 30 by to get 15?
Half.
Half. So what we do is we put a half in front of these, and we're done. So you put a half. So you can't like add or subtract at the end because that would throw off your zeros. But if you multiply by a half, see any of these zeros, it would still give you a 0.
What does the fourth degree mean?
So like, see all these x's, when you multiply them out, you get x to the 4th. So that's the highest exponent. Okay. Now, and like I said, the only other thing that sometimes if you look at the answers on these, they might multiply these out. But I don't always require that, so. Okay. All right, any questions on that? Okay, so that's it for 4.2. Any questions on 4.2? All right. All right, so this, so now we're going to go on to 4.3. And we'll just do a little bit on this. I just want to make sure that we can finish it on Monday. And that's really the main thing, is I'm looking toward Monday, I'm not worrying about having to finish this or whatever. Okay? So this section is on locating the real zeros. Okay? Now, the most important tool that you have in locating real zeros is the calculator. Okay? You punch it in the calculator and you're trying, the zeros are where it crosses the x-axis. Okay? So the problem is that let's say this is the graph and I want to find these three zeros. Okay, 1, 2, 3. All right. The problem is that what if you graph it and this is your window in your calculator and you only find the 1? Well, then you used a calculator, but you did not get the right answer. You have an incomplete answer. And so the purpose of this section is to give you some tricks to know when you have them all, or when you're looking at the right window in the calculator, so that you can know for sure, hey, I've got them all. All right, so that's kind of the whole point of this. All right, so the different ways, the different tests that we're going to use are the rational zero theorem. So that tells us what are some of the possible zeros. Descartes' rule of signs and the bounds of the real zeros and the intermediate value theorem, those all tell us where to look, okay, to make sure that we have the window set. And then the graphing calculator, then we're going to do second calc 0 to use. Once we know we have everything in front of us in the calculator, then we can use second calc 0 to find the tricky ones. Okay, so that's kind of the idea. All right, so first of all, the rational zero theorem. So to use the rational zero theorem, the possible rational zeros are plus or minus the factors of the constant divided by the factors of the leading coefficient. Oops. All right, but the caveat is that the polynomial must be in descending order. Okay, so otherwise that's not your leading coefficient. So that would throw you off. Okay, so what this is it's not telling you the answer, it's just telling you where to look. Okay. All right. So, well, I guess let's go back. Okay, so let's say we have this polynomial right here. All right. So the factors of the leading coefficient, or the constant, factors of -3 are 1 and 3, and you put plus or minus in front. Then the factors of the leading coefficient, 2, are 1 and 2, plus or minus in front. So then to simplify that, you only need to put the plus or minus in the very front, and then you have 1 over 1 is 1, 3 over 1 is 3, 1 over 2 is 1/2, and 3 over 2 is 3/2. So you kind of simplify the fractions. And if they're listed twice, you don't have to list them twice if they occur twice. So, but you put plus or minus and then parentheses. So there's really 8 possibilities here. Okay. All right, so go ahead and try practice 1A. All right, so Hannah, when you've got it.
I don't really understand it.
Okay, so what's the constant up there? What number is the constant?
5,
Okay. What are the factors of 5?
1 and 5.
1 and 5. So that's going to be your numerator, plus or minus 1 and 5. All right. What's the leading coefficient?
Two.
No. The leading coefficient would be the number in front. And since there's not a number in front, it's assumed to be 1. And so the factors of 1 are just 1 and 1. So you just have 1. And so then to simplify that, you just put plus or minus out front, and then in parentheses, 1 over 1 is 1, 5 over 1 is 5. So that's your answer right there. Now, I want you to look, though, at the actual graph. See, none of these are actually zeros. 1, -1, 5, and -5. It doesn't actually cross at any of those values. So what that means is that all the zeros for this are going to be like square roots. They're going to be irrational or complex. And so we're not going to be able to find these easily. But you try this first, the rational zero test, to find the easy ones first. Okay? So to test the possible rational zeros, use synthetic division, and then I'm going to add or the calculator. Because in reality, you would use both of those tools. Okay? So let's say we have okay. So first of all, let's list the possible rational zeros here using the rational zero test. Okay? So what's the factors of the constant? What are the factors of the constant?
Uh, 2, -2, 15, and -15. And then
Okay,
3 and
so
10.
first of all, let's just put the plus or minus in front, and then we don't have to worry about the signs. So plus or minus, okay, so 2 and 15. Are there any other pairs?
3 and 10,
3 and 10,
and 6 and 5,
and
1 and 30.
1 and 30, okay? So, see, you can see how this can get pretty crazy. Okay, now, what are the factors of the leading coefficient?
One and two.
Just 1 and 2, okay? All right, now, let's see if you can simplify that answer. So put them together, which is 1 plus or minus in front, and then parentheses, and then simplify all those. All right, so you should get plus or minus 1, 1 over 1, 30 over 1, everything over 1. So all of those. And then 1/2. But see, 30 over 2 is 15. So we already have 15, so we don't have to list 30 over 2. 15 over 2, 5 over 2. 6 over 2 is 3. We already have 3. So we don't need to list that. 3 over 2. 10 over 2 is 5. So we don't need to list that either. We already have it. Okay? So when you simplify, you don't have to include the duplicates. Okay? But still, that's a lot of numbers. That's a lot to check. So to actually find them now, what you do is you can either use synthetic division or the calculator. Now, I actually like using the calculator to kind of know where to start. So here, like, this looks like right at 2, it's going to cross right there. And 2 is on my list. So I put 2 in for the synthetic division. And if it's a factor, if it's a 0, I'll get a 0 at the end. So I do the synthetic division. I set it up. 2, -9, -18, 71, -30. And then I do synthetic division and I break it down. And I get a 0. So that's victory. When you get a 0, that means it's one of the zeros. How many of them are there going to be for this problem?
4?
4, because it's whatever the highest exponent is 4. Okay, now, so I got to find another one. Now here it looks like from the graph maybe -3, and -3 is on my list. So I'm going to try -3. But here's the trick, okay, is that you don't have to use the original polynomial. Use this one that's simpler and has one less term. Okay? So I'm going to put -3 in the magic box, and I'm going to try this. Okay? So what I'd like you to do before class on Monday is find the other 3 zeros. See if -3 is a 0. And then find the other 2.